In the initial lecture of finding out the number of factors, we saw the shortcut method to find out the number of even factors and the number of odd factors of a given composite number. Now in this presentation, we are going to revise our shortcut method and solve one example problem. So let us understand the shortcut method properly. We have a number 48. This is a composite number and we want to find out the total number of even factors and the total number of odd factors of this composite number. Now the step number 1 is to find out the number of prime factors, or you can say the prime factors of this composite number. And for that we will focus on the prime number which is smallest, not equal to 1, dividing 48 completely. And that prime number will be number 2. 48 when divided by 2 will give us 24. 24 is again divisible by 2, giving us 12. 12 again divisible by 2, giving us 6. 6 divisible by 2, giving us a prime number 3. So we will stop here, and in this way we have the prime factors of number 48. So we can write 48 is equal to 2 power 1, 2, 3, 4. There are 4 2's, so we have 2 power 4 multiplied to 3 power 1. There is only 1 3, so we have power equal to 1. Now we will leave this calculation here and we will move on to our general case. Let's say we have a composite number n, and this composite number n is having the prime factors a, b and c. A is having the power p, b is having the power q, and c is having the power r. And out of a, b and c, a is even prime factor, b along with c are the odd prime factors. Now what will be the number of even factors and the number of odd factors of this number n? Talking about the number of odd factors, it will be equal to q plus 1 multiplied to r plus 1. Now observe, here we have not included p. The reason is p is the power of even prime factor, and when we are finding out the number of odd factors, we only include the powers of odd prime factors. B and c both are odd prime factors. B is having power q, c is having power r, so here we have q plus 1 multiplied to r plus 1. Now moving on to the number of even factors. The number of even factors will be equal to the power of even prime number we have here, which is p, multiplied to the number of odd factors, which is equal to this. So we have q plus 1 multiplied to r plus 1. For example, if from here after the calculation we have alpha, then the number of even factors will be equal to p multiplied to alpha. And there is one more way to find out the number of even factors. If you have already calculated the total number of factors, which will be equal to p plus 1 multiplied to q plus 1 multiplied to r plus 1, then you can subtract alpha, which is the number of odd factors, from the total factors. Let us now implement all these in this particular example to make everything more clear. If we need to find out the total number of factors of the composite number 48, it will be equal to 4 plus 1 multiplied to 1 plus 1. 4 plus 1 is equal to 5, 1 plus 1 is 2, so 10 is the number of total factors. Moving on to the number of odd factors. When you observe the obtained prime factors, you will find this is even and this is odd. So we will only consider the power of odd factor. So we will have 1 and we will add 1 to it. From here you can see. So 2 is our answer. The number of odd factors of 48 is equal to 2. Now what about the number of even factors of the number 48? This should be equal to total number of factors, which is 10, minus the number of odd factors, which is 2. So 8 is our answer. Or you can follow this particular formula. You will have 4, because 4 is the power of even prime factor, multiplied to 2, because 2 is the number of odd factors, and this will give us the same result. So this is all for the revision of shortcut method. Now we will move on to our example problem. In this example problem, we need to find the number of even factors of 60. So the given number is 60 divisible by 2, giving us 30, divisible by 2, giving us 15, divisible by 3, finally giving us the prime number 5. So 60, this will be equal to 2 power 2. We have two 2's, so 2 power 2 multiplied to 3 power 1, only single 3 is there, multiplied to 5 power 1, only single 5. Now when you observe, you will find 2 is our even prime factor, 3 and 5 are our odd prime factors. The number of odd factors will be equal to 1 plus 1 multiplied to 1 plus 1, giving us 4. Moving on to finding out the number of even factors of 60. This will be equal to 2 multiplied to 4, giving us 8. 2 is the power of even prime factor and 4 is the total number of odd factors. And to find out number of even factors, we need to multiply them. From here you can see that. So this is it for the example problem. Let's move on to the homework problem. You need to find out the number of even factors of number 420. Try to solve it, and once you have your answer, don't forget to post it in comment section.